Today I'll be talking about the Euler's method formula for my EM3 assignment. So for the Euler's method formula, the formula is as given. Yn plus 1 equals to yn plus h multiplied by the function xy, where the function xy represents the derivative of function y with respect to x. And yn plus 1 equals to the next estimated y value corresponding to the next x point, and h is the step size. So for the function of xy, which equals to x squared plus 1, the initial condition that is given is when x equals to 0, y equals to 1. And for the approximated y, when x equals to 1, y equals to unknown value. So as you can see here, the step size I have chosen is 0.2. So as 0 approaches 1, it is an increment of 0.2. So as you can see here, when x squared plus, there's this x squared plus 1 over y, I've substituted the xn and yn into the formula or into the function xy. When I substitute xn equals to 0 into here and yn equals to 1 into here, it gives me a function of 1. And I substitute the function over here, then multiply by the step size plus the yn gives me a resulting value of 1.20. And as the step size increases, the yn plus 1 increases. So the final value will be given as 1.9096. When the x equals to 1, the y approximate value is 1.9096. And as you can see here, this graph represents the step size as it's increasing. The y value will increase as x approaches 1, it reaches 1.9096 here. So this is the Euler's method formula represented on an Excel spreadsheet. The x represents 0.2, the step size, which is the column, plus 0.2 is increases until 1. And the y represents the formula, the Euler's method formula, and the dy over dx represents the function x squared plus 1 over y. So as you can see here, using all three columns, I've got the resultant value of 1.9096, which I've gotten previously. And to compare it to the general solution, I've used the general solution problem that is given to me. Dy over dx equals to x squared plus 1 over y. And the initial condition of x equals to 0, y equals to 1. To solve using the general solution, I separated the variables, integrated both sides, and take the results of integration and applied the initial condition of x equals to 0, y equals to 1. Then I substituted back the c equals to half into the equation to find y is x when x is 1, y is y exactly, which equals to 1.915. So using Euler's approximation and using the general solution, you can see that the Euler's approximation is very close to the exact solution, but it has only a percentage error of 0.28%, which is less than 0.5%, which validates the use of the Euler's approximation and Euler's method formula to find an unknown variable of y or x for the first order ordinary differential equation. You can solve it using the Euler's method formula.